All right. Hey, everyone. So today we're going to talk about a new feature in Consul 1.10, transparent proxy for Consul service mesh. I'm Nitya, and I'm an engineer on the Consul team.
I'm Kyle, also an engineer on the Consul team.
Sweet. So yeah, we'll kick it off with an agenda. So we will focus today on transparent proxy on Kubernetes and what it enables and why it's nice to use. We'll have two demonstrations, a service to service use case, which is a bit simpler and demonstrates just kind of how easy it is to use and the defaults, and a more complex Ingress use case, since we're excited to show you what this new feature can enable and give you a better idea of the configuration you can tweak with this feature. And then we'll circle back and recap. So why t-proxy? Well, service mesh users want to use the mesh for security and traffic configuration and not have to change their applications or think about what the service mesh is doing under the hood for them. So transparent proxy makes it so that apps don't need to be proxy aware. On Kubernetes, users typically use kubedns to address services within the cluster, and transparent proxy allows you to continue to do that and leverage that tooling, which means you don't need to make changes to your application in order to use the mesh. Also with t-proxy, IP tables rules enforce that all inbound and outbound traffic for your pod go through the sidecar proxies. And we'll talk more about this in the example. It also simplifies and makes upstream configuration more dynamic. So let's walk through an example. Before t-proxy, here's what service-to-service communication looks like. This front-end application has an annotation for its upstream backend, indicating that it wants to reach backend at port 1234. So whenever front-end dials the backend, it'll need to use localhost 1234, which will dial its local Envoy proxy. And Envoy is configured to know that 1234 is for the backend application. And in order to have traffic go through the proxies, you do explicitly have to dial localhost 1234. And so it's not enforced kind of through the proxies before this transparent proxy feature. So with transparent proxy, we have something that looks more like this. Service authors can use kubedns to dial their services, and that traffic is always directed through the Envoy proxies. So traffic cannot circumvent the mesh without explicitly declaring that it should. So Consul will configure the proxies to know about any upstreams that they can talk to via service intention config entries. So if you want two applications like front end and back end to talk to each other, you just need to create an intention that allows that, and then dial the kubedns address just like you would without the mesh. So this is one of the demonstrations that we'll walk through today. All right, so we're gonna walk through a demo where we'll deploy Consul. We'll deploy a front-end and back-end application where front-end reaches back-end using the kubedns address. And we'll at first not include the intention, which means that traffic will not reach the backend. And then we'll add the intention to show how the mesh is dynamically configured to allow that traffic. So first we'll kick off the installation there. And let's take a look at the console values file. So this is the values file that's being used to install Consul here. So we've turned on ACLs, which means that by default, applications will not be allowed to talk to each other, and we'll need to add an intention to allow that explicitly. We've got some servers and clients, and then we've enabled connect inject, which is what allows you to use service mesh and injects the sidecar proxies into your application. We've also enabled transparent proxy, which also already defaults to true, but just to be explicit here, we've turned that on. And we've also enabled the controller, which allows you to use custom resources in Kubernetes for config entries. So that has been deployed. Cool, and so that's up and running. So now we just need to deploy front end and back end. So let's look at the YAML for that first. Okay, so for front end, we've got a service, and a service is used to expose an application in Kubernetes, either to other services via kubedns. So this means that I can reach front end at frontend.default.service.cluster.local, or also from outside of the cluster. And we've also got a service account here for front end, which is required when ACLs are enabled and will allow front end to get an ACL token to use. And we've also got a deployment for front end. And the thing to note here is that front end has just an environment variable here about how it's going to dial its backend, and it can use the backend's kubedns address, which is backend.default.service.cluster.local. So this is exactly what it would do even if this application was just running on Kubernetes without Consul service mesh. And then front end is running on port 9090. So we'll port forward and go take a look on front end, whether it's successfully dialing its backend. And lastly, we've just got a service defaults here, which tells Consul that front end is an HTTP application and can leverage Consul's L7 traffic routing, splitting, config entries, and intentions. So we've got a very similar setup for backend. It's got a service account and deployment, and a service defaults. And then we've got this service intentions here that we said we will not include to begin with, and see kind of what happens there. So let's pick this up. Right, so those are starting up, and once those are up, we can port forward to front end and take a look. Cool. So we'll port forward. And take a look at the UI. Which might take a little while to come up and show us. Okay, there it is.
Cool.
So yeah, so this is showing us that front end was not able to reach backend at this URL. The response was a 500, and that's because we don't have that intention yet. So let's make sure we add that. Actually, I'm going to kick off the port forward here. So that cool. So that intention has been deployed, and so we should be able to see that traffic actually come through soon. So this might take a little bit too, but we didn't have to make any other changes. So we just have to wait for it to start working. Cool. So yeah, now front end is able to dial backend at this kubedns address. And we see that the response is a 200. So yeah. Cool. Yeah. So now that we've covered the service to service use case, Kyle is going to cover the Ingress use case.
Cool. So just to recap, we just showed you a demo of service to service traffic using transparent proxy that highlighted using kubedns as a means to determine where your traffic is going through the mesh. So what I'm going to show is a demo which is a little bit more complicated, but also uses the sidecar to direct traffic throughout the mesh. And that's using an Ingress resource. So what we have is a Trafic Ingress gateway, and then with it, we would have an Ingress resource, which helps define rules for Trafic about how it would actually route traffic throughout the mesh. So the difference between the two demos is that one is using kubedns and the other, the Trafic Ingress, is using pod IPs to direct traffic. So here we have simply rules set up for a host, as well as the backend service, which it will talk to. And so what we'll have is traffic will come into Trafic. Trafic will then figure out which service it needs to talk to and direct traffic directly to the pod IP of that backend service. So I'll go ahead and show you a demo now. All right, so what we'll be demoing is a simple Trafic installation and Consul installation along with an application that we'll try to reach through the Ingress gateway. So in order to do that, we just have to basically deploy those three things. And so I'll just kind of just go ahead and do them. So first we'll install Consul. And in doing that, we're just using a very basic Consul values.yaml file for a Helm installation. This is all fairly standard. I'm just using a dev image of my own. TLS is enabled, ACLs are enabled, and then again, connect inject is enabled. As Nithya mentioned, t-proxy is defaulted on, so I just don't have that listed here. So very simple. So I'll just do a helm install Consul. And that'll take 30 seconds or a minute. And so in the meantime, I'll show you what the Trafic values file is. So we take a look at that. This is just a fairly basic Trafic values.yaml file that I grabbed from their website. All of this is fairly basic. The only things that really need to be changed are down here in the RBAC rules. We had to set the service account to be explicitly named the same as our actual service. It just happens to be a requirement within Consul that your service and service account have the same name. That's what we use for authorization. And then again, one other thing is Trafic's going to deploy a deployment. And that deployment we want to actually add a sidecar to, so that when traffic comes into Trafic, it can then go into the mesh and off to the service. So in order to do that, what we do is we connect inject the deployment for Trafic, and then open up a couple extra ports. So Trafic needs to be able to have traffic come into it and have that into the pod and have it hit the Trafic service without hitting the proxy first. If we didn't specify these exclude ports, then all of that traffic would go into Envoy first and not make it to the Trafic service. So we set up the ports that the deployment needs, as well as one additional, which is to set up an exclude of the CIDR range, which covers the Kubernetes API. So Trafic needs to be able to hit the Kube API to grab information about services, grab information about endpoints, objects, and that sort of thing. Since it's managing routing for a service, it needs to be able to grab access to that. So in my case, this just happens to be my Kube service. So if you were to use the same thing, you just point this to your Kube services IP. So back to Consul. Should be up and running. Looks like it's all up and running. All right. And then I'll just go ahead and install Trafic. Just like that. And that only takes a few seconds usually. All right, cool. So it's coming up and you can see that it has a second container added. So that was actually our sidecar container for mesh traffic. Now I'll let that come up in the background. So now that we've got Consul and Trafic running together, what we'll need to do is then just simply deploy the application. So Trafic has a demo application called Who Am I, which allows you to just curl through the Trafic Ingress gateway, hit the Who Am I backend service, and it'll return information about what it is. So in our demo, that's what we're trying to do, is have traffic come in into the Trafic gateway, go through the controller, and make it to the through the mesh to the backend. So let's take a look at the deployment for that application. So very similar to what Nithya was talking about earlier, we just have a simple service account and service, which are like the front of this backend. Then the actual deployment itself is very standard. This is a copy, exact copy of their demo. The only difference is I've added a service account because we're using ACLs, and then added an annotation that says, please connect inject this. So that we can just simply apply. Now, Trafic itself is actually managing the routing. So I mentioned earlier that we're not relying on kubedns here. So what happens is when it comes into the Trafic controller, it then figures out the pod IP and sends traffic to the pod directly. And so in order for that to work, what we have to do is apply a service default to the deployment in Consul. And so what that looks like is it's a CRD, and we simply say that transparent proxy should allow this pod or this application to be dialed directly. So that means we don't reject traffic that show up directly to the IP address of the pod. So I will just apply that. And we should have our pods coming online. Okay, everything's online. What's next? Oh, we also have to create an ingress resource so that Trafic knows how to actually direct the traffic. So I have an ingress resource that I just copied directly from Trafic's example. And what this is doing is it's setting up a rule for if I ask for a host, who am I, when I reach the ingress gateway, it knows to then go back to the backend service, who am I. So I'll go ahead and also apply that. And now everything should be set up and ready to go. So if I do kubectl get services, I now have an external IP for my gateway, for my ingress, and I should be able to curl that ingress port 80 and pass host header, which we just talked about as the ingress resource. Who am I? So it should now know to go to the who am I deployment, the who am I service, and reach that for this request. So looks like we forgot something. What happened here was that Consul actually rejected the request. And the reason for that is because we have ACLs enabled. And so that says that that tells the system that we're not allowed to pass traffic unless it's been explicitly put in as a rule. So what we can do there is to add an intention. And so for that, it just looks like this. We're creating an intention that says the Trafic service is allowed to reach the destination service, who am I? So if I were to simply just apply this, we would now be able to actually pass all the way through and get a response back. So this worked. That's great. It tells us information about the pod that was actually the pod IP that we actually reached. And yeah. Cool. So that was our demo of the Ingress gateway using Trafic. So that was quite a bit of information. lots of YAML files, lots of text to try to consume and hold up here. So I thought I would just kind of give a higher level overview of what we were doing, showing how the resources interact with each other, and kind of hopefully give you a better idea of what was going on here. So again, we deployed a Traefik Ingress gateway that takes an Ingress resource and it connects a host and a service together so that Traefik knows how to accept that host header and forward it to the backend service. And so Traefik itself, we deployed as being connect injected as well. So that allows us to take traffic that's coming into the gateway, pass it down to the Envoy proxy and go across the service mesh to a backend service. So we had to do three things for Traefik to actually manage this. One was to simply connect inject it. That creates the sidecar. The second was to set up a few excluded inbound ports. And so again, these are the ports that Traefik is actually using. And what we want to do is make sure that traffic can come into Traefik and not hit the Envoy proxy directly, so that it can then take the traffic and route it as it sees fit. So we set up some excluded inbound ports for that. And then also Traefik needs to reach the Kube API server. And since it's actually managing a service, if you will, it needs to know about what endpoints are part of that service. And in this case, an endpoint is the whoami service itself, which is running connect injected. So that's the Traefik pieces of it. Consul is then responsible in the middle for managing that traffic from Traefik all the way over to whoami in the backend, right? So Consul just simply needs a few things. So one of them is the service so that you can actually connect inject the service for the deployment for whoami. The second is a simple configuration for a service default that says, hey, please allow this service to be dialed directly, not using kubedns, but actually using the pod IP. And if you recall, Traefik actually routes directly to the pod IP, not using kubedns. And then finally, we have a service intention, which is what we're using to tell Consul to actually allow the traffic to go from one Envoy proxy to another Envoy proxy. So I'll spare the rest of the details, but that's essentially what all the resources that we needed to get the demo to work. So that's that. Thank you. Check out Consul Helm and Consul Case on GitHub. I also have the Traefik demo up on GitHub as well, so you can play with it as you see fit. This is all featured. This is our new big feature in Consul 1.10. So thanks so much. Appreciate it.
Yeah. Thank you, everyone.
All right. I should have Nitya and Kyle here with me. Let's see. Yeah, there they are. Awesome. Thank you both for that presentation. We'll go ahead and ask a few questions here. I'm a huge fan of Transparent Proxy. I've been playing around with it myself, so thank you all for the work that you did on it. I think it makes using mesh a lot easier. Nitya, you were answering a question here about upstream URIs. I thought maybe you could share kind of that information with why we were using those in your demo app and how they apply to Transparent Proxy, if at all.
Yeah. Can you hear me?
Yeah, you're coming in a little fuzzy. I don't know if it's just me.
Okay, yeah.
Is this a little better?
There we go.
Yeah. So the upstream URI was something that was specific to the front-end app. And you wouldn't usually have to use that. Sorry, I'm getting a bit of an echo here. I'm just gonna, okay. Yeah, so you wouldn't usually have to use that environment variable. That's not something specific to like all pods that you deploy to the Connect service mesh. That was just something that app uses in order to know what backend it's trying to dial. And before t-proxy, it would have been useful to set something like the local listener that you need to dial to reach your backend. But with t-proxy, since you're just using a service URL, if front end already knows that it's going to talk to backend, then it could have just used that service URL like in its application logic. It wouldn't have to pass in that upstream URL there.
Awesome, thanks. Kyle, I see you in here answering the question about Trafix, so maybe we'll share that with the group. Does it support Trafix Ingress route custom resource, or does it have to use only the Kubernetes Ingress resource?
So I didn't show that in the demo, but you should be able to use it. I have seen it work. So yeah, it does work with the CRDs.
Awesome, thank you. One of the things, and then maybe we can touch a little bit more on this, is I know that you were answering a question on there about service intentions. In the examples that you all gave, ACLs are enabled, which is going to have you can have a default deny in place, but service intentions you don't necessarily need if you're just going to open up traffic to everything, right? Or maybe talk a little bit about just how service intentions relate to t-proxy overall.
You want to take that one, Nithya?
Yeah, sure. So service intentions are used when you have an ACL default deny policy. So in Kubernetes, you saw that both me and Kyle in our demos had that managed systems ACLs value set to true. And so that's enabled ACLs, and it's set the ACL default the ACL policy to be default deny. So that means that by default, no two apps can talk to each other. And so you do need to explicitly then set that intention so that in the first case, front end can talk to backend, and in the second case, the Ingress router can talk to who am I.
And we're actually
go ahead.
Sorry. In the context of t-proxy, we're actually using these intentions to set up the IP tables rules, which is defining how everything's being. Sorry for the echo here.
No, you're good, Cal. Cool. No, I think that's a really good point. Actually, you led me into another question I think is always good to let people know. If I'm interested in using t-proxy, but maybe I was using Consul Connect before, is there any considerations that I should have, or is there anything that I should do to make sure that t-proxy works correctly for me when I'm upgrading to 1.10?
Yeah, so when you're upgrading, you will need a Kubernetes service for every single app. So that's how we tell Consul, oh, okay, this is a service in your service mesh. And you typically deploy Kubernetes apps with Kubernetes services anyway, because that's how you would get a URL to talk to those services. So you will need that. And then if you have existing services that kind of weren't using this t-proxy mode before, after you upgrade, you will need to restart all of your pods so that they're managed by the new kind of central system that we have for managing pods now.
Thank you. Kyle, I'm going to throw this your way because you showed us the big architecture graph. There's a lot of resources, obviously, that you got to compile for this. Any recommendation for folks that want to be able to build out all the configurations, or any templating that they could use?
Specific to t-proxy, there's not a whole lot, right? But in terms of setting up in my demo, setting up Ingress resources. The three things that we had to change were connect injecting the Ingress controller and then setting up the exposed ports. Typically, those are just the container ports of your Ingress controller. So it's really just kind of looking at what your Ingress controller needs in terms of its deployment, and then setting up exclusions for those specific ports.
Awesome. All right, we'll give it a second here to see if we have any last second questions coming in. Again, as a reminder, all these sessions, you got a couple of shout outs. Awesome presentation. I think the demo was fantastic. So make sure I let you know that a couple of people chime in there. These all have been recorded. We are going to make sure we post all the slides and everything, so folks are going to be able to access the demo repos if they want to try this themselves. Let's see. Okay, well, we are at the, let's see. So we did have a question about Traefik middleware. Kyle, I don't know if when playing around with it at all, do you know, is it going to impact any of the configurations you have set up there, or how does it play with some of the Traefik middleware components?
So I didn't get too far into the middleware components, right? That's part of the Traefik CRDs and that sort of stuff. So I do know that it does work with that. I just didn't play around with that. I had another colleague also playing around with this at the same time. So they were able to get it to work with the middleware and the CRDs.